787, when we were looking at what's the right material for the airplane, we looked at the cost to manufacture, we looked at the benefits of the material, and we made this decision to build the first commercial composite airplane.
We were very focused on commonality between the 787 and the 777. Its operating philosophy, where things are in the cockpit, how you invoke certain functions when you fly the airplane. A crew that understands how to fly the 777 will have a very easy time transitioning into the 787.
All the power that drives all the services on the airplane come from the engine. In the past, all that power came from taking what's called compressed air off the engine and driving things pneumatically. With the 787, we decided, let's do something different, and that was to go to what we call a more electric architecture.
For us, the design always is having to take what exists today and figure out how to build on it in a way that is intuitive to the flight crews. We've got more display space than we've ever had before. We've got head-up displays that give you all the flight information you need while you're looking out the window, electronic flight bag displays that give you all the information you need about maintenance of the airplane and about the logbook. We've gone to a more electric airplane, so rather than having a high-pressure pneumatic system, we've got an electrical power system of very great capacity, but as a result of that, the airplane burns less fuel in cruise because we can more efficiently extract power from the engines.
So instead of taking bleed air off the engine, which is off the compressor right here, decided to take shaft horsepower off and drive some very large generators. There's a 0.5 megawatt of power being generated by each engine in flight up to that amount. The electrical power through wires is taken onto the aircraft and very efficiently run all the services on the airplanes. A high bypass ratio engine to measure how efficient and how quiet an engine is going to be. We took a real step change on the 787 one, which makes for a very quiet engine and very fuel efficient. So
we chose carbon fiber. It's an exceptional aerospace material. It's got great durability. It's very strong for its weight. And for the first time, we used it for primary structure. One of the properties of composites is the ability to build exactly the same piece over and over again. You can actually repair it just like you would a metal or an aluminum airplane, but you can also do a composite repair. So the airlines actually have more options. We chose the right material for the right application. Carbon fiber allows us to put those larger windows in so that all the passengers can see out the windows without adding a lot of weight to the airplane. One of the primary goals on the program was to use all of this technology to reduce fuel burn, reduce emissions, and make an airplane that was really good for the environment.
And this is the first time we've also said, but what's going to make a pilot feel good? What's going to make them want to come into that cockpit and fly that airplane? It can't just be functional, it's got to be cool.
This airplane is going to be something really big in our industry for a long, long time. And when I see one fly overhead and know that I had some little part in making that happen, it's going to be a very rewarding feeling.
Soon, you too will experience air travel like you have always wished it could be. In the months ahead, we will be sharing this exciting turning point in aviation with you. So please, sit back, relax, and prepare yourself for the future of aviation. The Boeing 787 Dreamliner. How will you travel through life?